Today, section 8.2, we're going to learn two more factoring techniques. One is called factor using the greatest common factor, and one is called factor by grouping. So, anytime you see the word factor, the very first thing you should always look for is a greatest common factor. Greatest common factor is typically abbreviated GCF. That way you don't have to write it all out, greatest common factor every time. What do I mean by greatest common factor?
The highest number they all share in common?
The highest number and maybe variable that they all share in common. For example, I might give you 15x plus 30. What do 15x and 30 have in common? 6 and 5, even better than that though. 15. The biggest thing they have in common is a 15, don't they? What do you mean by they have 15 in common?
It goes into both.
It goes into both of them. So what we're going to do, factoring by using the greatest common factor, is going backward on the distributive property. So I'm going to take that 15 and put it out front. That's the thing they have in common. And then I have to ask myself, 15 times what will give me a 15x? An x, so I put an x right there. And then 15 times what will give me a 30? A plus 2. So that would be considered factoring using the greatest common factor. Questions on that? Okay. How about 8x squared plus 12x? You look at your numbers. 8 and 12. What's the biggest thing that 8 and 12 have in common? A 4. How about your letters this time? They both have an x in them, don't they? This one has an x. This one has an x squared. But what they have in common is they both have one x. So I put an x out front this time too, because they both have an x in common. All right, then I put my parenthesis. 2x plus 3. Excellent. Why 2x plus 3? Right. To get the 8x squared, I need 4 times 2 to get the 8, and then I need an x and an x to get the x squared. And then the plus 3 because I need 4 times 3 to give me the 12 back. Questions on that one?
I think I just might get a little confused. I put an x next to it.
Right. You shouldn't have an x next to the 3 because then a 4x times a 3x would give 12x squared. So you don't want an x there. What times 4x gives me 12x, just the number 3. All right, how about, I don't know, how about 9x to the 5th plus 18x to the 4th plus 12x squared. All right, it gets a little harder when they get a little bigger like this. Now we have to look at all three numbers. We have to look at 9, 18, and 12. What do 9, 18, and 12 all have in common? 3. They can all be divided by 3, can't they? How about your x's?
Well, you're going to put an x in. So they all have x in common.
They all have x in common, but I think I can do a little bit better than x. X squared, very good. Why x squared?
Because the square goes into 2, 4, and 5, you just have to put an x inside of the parentheses.
Correct. The x squared goes into the 2 and the 4. That's correct. So basically what you do with your x's are easy. You look at all the x's and which one do you always pick? The smallest one. So you look at all of your x's in the problem and you pick the smallest one. And again, it's interesting that the numbers are usually harder here. It's usually harder to figure out what to do with the numbers. All right, so now I put my parenthesis. I've got a 3x squared. I need a 9x to the 5th, which means exactly I need a 3 x cubed. Why 3x cubed?
2 plus 5, 2 plus 3 equals 5.
Cubed. You said I know squared. Right, because 3 times 3 gives me 9. And then when I multiply x squared times x cubed, I add my powers, I got 5 x's altogether. That's x to the 5th. Plus the next one. 6x squared, excellent. Because 3 times 6 gives me 18. X squared times x squared is x to the 4th. And the last one. Just plus 4. No x on the last one. Because I already have x squared, I need x squared. I don't need any more x's. All I really need is 3 times 4 to get to 12. Questions on that?
What does this get used for?
What does this get used for? That's a wonderful question. We will get to that.
I'm not going to answer you right now.
And I can't answer you today. We will get to that soon, though. What is factoring good for? Turns out it's good for quite a few things. Well, I'll tell you what we're going to use it for. We're going to use it for solving equations. And then we'll talk about why would you want these kind of equations. So we'll get to that. Right now, it's just you got to learn the skills. Once you get the skills, we can tell you what it's good for. All right, how about another one of these? I don't know, somebody give me a good number.
6.
6, that's a good number. 6. X squared y cubed. Give me another good number.
9.
9. Minus 9 x cubed y to the 5th. Oh, that's enough probably. Equals. Doesn't really, the first 3 examples I did all had pluses in them. Really doesn't matter if we have a minus there, does it?
No.
I don't think so. Okay, well, look at your numbers. 6 and 9. What does 6 and 9 have in common?
3.
Oh, 3. Look at your letters. What about the x's? X squared, because that's the smallest one, isn't it? This one has an x squared, that one has an x cubed. It's the smaller of the two.
Y cubed.
And then excellent, y cubed. The fact that we have another letter in here really isn't that big a deal. We look at our y's, we have a y cubed and the y to the 5th, we take the smaller one. Parenthesis. What's left over?
2y.
2.
2.
It's just 2, isn't it? Because I've already got the x squared, I've already got the y cubed. 2 times 3 is 6. Minus 3xy to the 2nd. 3 times 3 to give me the 9. X squared, and I need another x to get x cubed. Y cubed, I need 2 more y's to get up to y to the 5th. I think that's right. Questions on that one? Okay. Here's one that usually causes problems. How about 10x cubed minus 5x squared?
Squared.
5x squared is the common thing.
Parentheses 2x.
Minus 1. Very good. And that's the thing people usually forget. Why does there have to be a minus 1 right there? Excellent. 5x squared times 2x gives me the 10x cubed. But then I need to have something inside this parenthesis. I need 5x squared times something to get a minus 5x squared. So 5x squared times what gives me that minus 5x squared? It's a 1. And when the entire thing factors out, the whole 5x squared comes out, quite often people will forget the 1 in there. Okay, but again, if you do a quick multiply and check, you realize you'll have to have that 1. Can't go away. Questions on that? All right, when we were doing some of the homework problems, I warned you, one of them we had to factor more than once, and I warned you that was going to happen some more. Let's do some examples like that. How about 5x squared minus 20? What would you do with 5x squared minus 20? Well, whenever you see the word factor, the very first thing you should always look for is a common factor. Do 5x squared minus 20 have a common factor?
5.
It has 5 as a common factor. So I'm going to put the 5 out here. What goes inside my parentheses?
X squared.
X squared minus 4. Excellent. And a lot of people will be very tempted to stop right there and say, I factored, I'm all done. You're not all done, though. Why not?
X squared.
The x squared minus 4 factors more, doesn't it? How does x squared minus 4 factor? That's an x plus 2x minus 2. How do you recognize that's x plus 2x minus 2?
There's a 0 in the middle, which means one's got to be negative, one's got to be positive to cancel out.
Two things. There's a 0 in the middle. There's no x piece. And this is a perfect square, and that is a perfect square, and there's a minus in the middle. That's really what we're looking for. We have a square minus a square. That tells us we can factor more. Okay, so watch for that. It's very easy to take the 5 out and think you're all done. But for that problem, you're not. You can factor more. The x squared minus 4 factors as x minus 2, x plus 2. Questions on that? All right, let's see if I can come up with another one of those. How about, I don't know, 3x to the 4th minus 27x squared. Once again, you see the word factor. When you see the word factor, you should always begin by looking for a GCF, greatest common factor. Is there a greatest common factor?
Yes.
Yes, it is.
3. 3x squared.
3x squared, excellent. So we take out 3x squared. What's left over? X squared minus 9. Then you got to ask yourself, this new piece left, is it done or can I do more? You can do more. It factors as
X minus and x plus 9.
X, not 9, but rather
3.
3. Right. Final answer should be 3x squared times x minus 3 times x plus 3. Uh-oh. Oh, out of paper. Flip it over, I guess. How about 2x squared minus 10x minus 12? How would you factor that? 2 is the GCF, so you take the 2 out.
2x. Or no, 2x. That's right, because x is the smallest.
Ah, but there's no x way out here on the end, is there? So in order to be able to take an x out, I have to have an x in every single piece. There's no x in this piece, so I can't take an x out. The only thing they have common is the 2. So I put a 2 out there. What's left over?
X squared.
X squared
Minus 5.
minus 5x minus 6. Questions on that? You do that on the test, and you're really happy about it. And then you get your test back, and the teacher takes points off. Why? The x squared minus 5x minus 6 factors more. And again, that can happen. Quite often, you're going to have to factor more than once, and this is a good example. So what's going to happen is you're going to have this 2 here, and then you're going to do this 2 parenthesis thing. It's got to be x and x. I need to be able to multiply to be a negative 6 and add to be a negative 5. I don't think negative 2 and negative 3 work. Because what's negative 2 times negative 3? Positive 6. Again, very tempting because negative 2 and negative 3 does give you the negative 5. So the signs are wrong.
Negative 6, positive 1.
Negative 6 and positive 1. Those multiply to be a negative 6 and also add up to be a negative 5. There's the right answer. Okay, so again, watch out for that. That happens quite often. You factor once and you're happy. You think you're all done. But very often you have to factor more than once. Questions on that? All right, the last thing we have in this section is something called grouping. Grouping is going to look like this. I'm going to say factor. We might have x cubed plus 3x squared plus 5x plus 15. I see the word factor, so I look for my greatest common factor. 1. Why 1?
Because
1 goes into all of them.
One's in front of the x cubed.
Because there is a 1 in front of them. So my numbers are 1, 3, 5, and 15. They have a 1 in common. And there's no x in common. Why not?
Because 15.
15 doesn't have an x. Okay, so there's nothing in common here. Now, what happens? Notice how many pieces there are. How many pieces are there? There are 4 pieces. When you see 4 pieces, that's going to tell you you're going to factor by grouping. And what I mean by factor by grouping is we take these things and we put them in pairs. That's why it's called factor by grouping. We put them into 2 pairs. I look at the first pair, x cubed plus 3x squared. Does that have a greatest common factor?
X squared.
Yes, it has x squared in common. So I'm going to factor out an x squared. What's left over?
1 plus 3?
X plus
Oh,
3.
X plus
X plus 3. I look at my second group. Does my second group have something in common? 5. All right, down to 5. What's left over? X plus 3. Now, I want you to notice something. I now have 2 pieces split by that plus sign right there. If I look at the left-hand side of that plus sign and I look at the right-hand side of that plus sign, is there something that's common to both pieces? The parentheses are exactly the same. If you're doing this correctly, those parentheses better come out to be exactly the same.
Can there be prime grouping?
What do you mean by prime grouping?
Like say like they don't, like you give us a question for some reason and they don't factor like that. Like will there ever be a case where it's prime or should they, every problem you ever give us factor like that?
If I give you a problem with 4 pieces, it should factor like this. I don't think any of the answers in this section, when you have 4 problems, I don't think they will ever be prime. Good question. So, the point is, if I look at this plus sign on the left-hand side and the right-hand side, they have something in common. In other words, this is our common thing. So if I take and I write that x plus 3 first, when I take the x plus 3's away, what's left over? X squared plus 5. There's my answer. Questions on that? Probably when we get to doing them, yep. Well, we're going to do some more here. We're going to do a couple more today. Okay, so how about x cubed minus 6x squared plus 4x minus 24. Once again, I would begin by looking for a GCF. Do I have a greatest common factor? No, I don't think so. They don't all have an x, and there's no number that's in common to all of them, is there? Because this first one has a 1. Okay, so once again, I notice how many pieces are there? There are 4 pieces. When I see 4 pieces, I'm going to group them in pairs. What's common in the first pair? X squared. And left over? X minus 6. Plus, what's common in the second pair? 4. And left over, x minus 6. Do you think you're doing it correctly?
Yes.
Yes. Why do you think you're doing it correctly? Those parentheses are exactly the same. And when I say exactly, I mean exactly. If this one's an x minus 6 and this one's an x plus 6, something's wrong. Okay? I mean exactly the same. Everything everywhere. What do I do now?
X minus, or minus 6.
I write down the x minus 6. And when I take the x minus 6's away, what's left over? X squared plus 4. Questions on that one? All right. Last one that I'm going to, well, no, I'm going to do 2 more. How about x cubed?
Will it always be within that x cubed, x squared, x nothing?
Yeah, it's always going to fall in that pattern. They're going to go 3, 2, 1, nothing. You're right. Unless I could go 4, 3, 2, 1, but then you would take a GCF out first. You would take the x out. So generally they're going to go 3, 2, 1, 0. Yep. X cubed minus, I don't know, somebody give me a number. 10, uh-oh. Minus 10x squared. Minus
I knew you could do that.
2x plus 20. One, two, three, 4 pieces. Anything common? No. Pairs. What's common in the first group?
X squared.
X squared. And left over. X minus 10. Second group. 2. And then what do I have left over?
X or x plus 10.
You can't do it. No, you just bring out the negative.
Okay, so this is something you have to watch for. If this is a negative right here, you're going to take out 2 as the common number, but you're actually going to take out a negative 2. So if this is a minus right here, we're going to take out a minus. Now, what goes in the parentheses? Negative 2 times what to get a negative 2x? That's an x. Negative 2 times what to get a 20? It's got to be a minus 10. And that's probably the single biggest mistake people will make. They'll remember to write the minus 2 here, but then they'll write x plus 10 in there. And then they've got a problem because then their parentheses are not exactly the same.
And negative 2 and negative 10 is
Positive 20, negative 2 and negative 10 multiplied together gives a positive 20. That's probably the biggest mistake people will make. When I put a minus right there, they'll forget that that one's got to be a minus. All right, so I take out the x minus 10. Left over?
X squared minus 2.
X squared minus 2. All right, one more of these, and then I'll give you guys some problems to practice with. Let's see, I'll write it on here, I guess. Huh?
Do you want this paper?
No, I'll write it right on here. This will work.
Can you show us one if there was a grouping with a GCF?
Well, then we're all the same.
A grouping with a GCF. Okay.
That'd be what you said earlier.
Would that be grouping though?
Yeah, just give me a minute. I can't make it up off the top of my head. I got to cheat a little bit. Okay, how about 2x to the 4th minus 10x cubed minus 8x squared plus 40x. All right, notice there's a GCF. What's your GCF? 2x. Even better than 2, there's an x in every one. All right, so 2x. Left over.
Yeah. That work.
X cubed minus 5x squared minus 4x plus 20. Now, here's the way I like to handle these. What I like to do, what do I do with this 2x all the time? Well, what I like to do is I like to write the 2x down, and then when I get all done, I know my answer is going to look like that. And what I like to do is just go off to the side somewhere and deal with this thing. Because otherwise that 2x is floating around and it sometimes gets in my way and it sometimes confuses me. So I like to just go off to the side, deal with this piece, factor it, and then I'll come back and I'll just plug in my answers. That's the way I like to handle it. No GCF anymore because we already took that out. How many pieces? 4 pieces. All right, so we take out of the first group x squared, and left over x minus 5. Second group, a negative 4. Excellent. This is a minus here, so we're going to do a negative 4. Left over x minus 5. Why minus 5? Because I need a minus 4 times a minus 5 to be a plus 20. At the same time, I need those to match up, don't I? So if I'd written that as an x plus 5 right there, I should recognize that I made a mistake. They don't match. All right, I take out that x minus 5. Left over x squared minus 4. So I come back up here. I put in the x minus 5. I put in the x squared minus 4. But Walker's not falling for my trap here. What's wrong?
I guess I'll go down.
You're still not done. Why not?
Perfect square.
X squared minus 4 fits into our difference of perfect squares pattern. So this is a pretty nasty problem. Why is this a pretty nasty problem? There's going to be 3 sets of parentheses, and we had to factor 3 times, didn't we? We first had to take out the GCF. We did that. We took out the 2x. Then we had to come off to the side and do this factor by grouping. We did all that. Then we finally get that done, and we notice that we have this thing which has difference of perfect squares. We can factor more. Final answer should be 2x, x minus 5, x plus 2, x minus 2. You end up with 3 sets of parentheses on that one. So again, watch out for those nasty problems. Sometimes, quite often, you have to factor more than once. And here's an example where you have to factor 3 times. Questions on that?
We'll have quite a few questions like that.
I wouldn't think you would have quite a few of those. Why not? Because it takes a long time. I think it would be more likely that you'll have just this part of the problem, and then you'll have separate problems that test this part and test your GCF. But I would say there will probably be at least one problem somewhere on the quiz or on the test that forces you to factor more than one time. Other questions? All right.